Everyone has seen Venus. Almost no one has actually seen Venus. From Earth, it glows brighter than any other planet. Calm, smooth, perfect, a white jewel in the sky. But that brightness is a disguise. Unfiltered Venus hides valleys, volcanoes, and ancient terrain beneath clouds so thick, light cannot pass. Is this what we're seeing, or just rendered? In the 1960s and 70s, the Soviet Union sent a series of spacecraft, the Venera program, to do what no one else had dared. The goal was simple, yet terrifying: land on a planet hotter than an oven, with crushing pressure and clouds of sulfuric acid. Early attempts failed spectacularly. Some probes burned in the atmosphere. Others were flattened by the pressure before they could even reach the surface. But the Soviets persisted. Each mission learned from the last. Each failure brought new engineering solutions. Venera 7, in 1970, became the first human-made object to transmit data from Venus' surface. It survived just 23 minutes, sending back temperatures of 475 degrees Celsius, hot enough to melt lead, strong enough to crush most spacecraft instantly. Soon after, Venera 9 in 1975 made history. It sent the first black and white images of Venus' surface. Boulders, flat plains, jagged rocks. The smooth, glowing planet now had texture, shape, and scale. Venera 13 and 14 went further in 1982. They captured color images, analyzed rocks, revealing a barren volcanic landscape, coated in layers of dust and pebbles. Temperatures soared above 470 degrees Celsius. Atmospheric pressure 90 times stronger than Earth's. Every picture, every reading, confirmed that Venus was not just an unbroken cloud. It was a planet with mountains, plains, and a geologic history of fire. The landers recorded chemical composition, soil density, and surface texture. Each byte of data reshaped our understanding. Venus was no longer a distant, glowing light. It was a world of extremes, a world no human could survive. Secrets hidden beneath clouds no telescope could pierce. Even today, the images and measurements from those early landers remain the most direct evidence of Venus' surface. Modern radar maps and orbital imagery trace their origins back to these daring Soviet explorers. They gave us our first, unfiltered glimpse of a world that had been invisible for millennia. Venus hides beneath clouds so thick, light cannot reach its surface. For centuries, astronomers could only guess what lay beneath. Smooth, featureless, glowing, perfect, but it was an illusion. The breakthrough came with radar. Radar pierces clouds. It bounces off the surface, revealing mountains, valleys, plains. In the 1960s, Earth-based radar pulses returned the first maps of Venus. Early maps were blurry, but they shattered assumptions. Venus was no longer a featureless sphere. It had volcanoes stretching hundreds of kilometers, mountains taller than Everest, vast plains. By the 1990s, NASA's Magellan mission mapped over 98% of the surface. Lava flows, tectonic ridges, impact craters. The planet revealed its geologic history: volcanic activity, crustal deformation, constant change. Radar taught a vital lesson: seeing isn't believing. Clouds deceive, glare misleads, distance hides the truth. Science pierces the veil. Venus is rugged, dynamic, alive. Every pulse tells a story. Every map uncovers a secret. Venus has always been a challenge to see. Thick clouds, blistering heat, crushing pressure. Even the strongest telescopes cannot pierce its veil. The Parker Solar Probe was built to study the Sun. It was never meant for Venus. Yet, during close flybys, it captured images in visible light. For the first time in decades, Venus could be seen in natural color. Its atmosphere alive, shifting, moving. Swirling clouds of sulfuric acid hint at storms and currents. Shadows reveal curvature. Occasional breaks show glimpses of the surface below. Fleeting, distorted, but real. Winds circle the planet faster than it rotates. Clouds reflect sunlight, making Venus the brightest planet in our sky. Beneath this shine lies a harsh, unyielding world. Parker's images complement radar and infrared data. They reveal motion, cloud structure, and light reflection. Venus is dynamic, alive, constantly reshaped. Patterns hint at energy transfer and possible volcanic influence. Exploration often comes unexpectedly. Instruments meant for one purpose reveal new worlds. Venus is still partially hidden, but through Parker's eyes, it becomes more real than ever. For centuries, Venus was thought lifeless. Thick clouds, a smooth, unbroken surface, a world frozen in time. But radar and orbital imaging tell a different story. Vast volcanic plains, towering shield volcanoes, lava flows stretching hundreds of kilometers. Some regions appear young. Volcanic resurfacing is ongoing. Infrared hotspots hint at recent lava flows or active vents. Tesserae, ridged regions, show Venus crust is moving and deforming. The atmosphere carries sulfur dioxide, replenished by volcanic activity. Venus is alive, geologically, under clouds that hide its secrets. These signs challenge old assumptions. Venus is not static, not a lifeless twin of Earth. Every lava flow, ridge, and hotspot is proof the planet reshapes itself quietly, dynamically. Studying these patterns teaches us about planetary evolution, climate extremes, and the boundary between habitability and runaway greenhouse effects. Venus is both familiar and alien, harsh, dynamic, unforgiving, and as scientists continue to observe and analyze, every measurement brings us closer to seeing the planet as it truly is: real, unfiltered, alive.